Yesterday we started quadratic functions and we were talking about the vertex form. And with the vertex form we were able to come up with our vertex, H and K. And then we found all the different parts. Well, today we're going to go to a different form because quadratics can be written in two different forms. Vertex form and then standard form. So on the next page we have standard form. So let's go ahead and write what the standard form is. It is y equals ax squared plus bx plus c. So it needs to be in descending exponent order. So that means the biggest exponent's first. Quadratic, it's always a 2 as our exponent. And then it's the exponent of 1 and then no variable at all. So if it's not in that form, you would put it in that form. The direction of the opening, it's either opening upward like this whenever A is positive. But it opens downward if A is negative. It's one or the other. This or this. Okay? So it's called the leading coefficient. Okay, the axis of symmetry. It's found by doing a little formula. And it's called x equals negative b over 2a. When you find your axis of symmetry, you draw your dotted line down the middle. So that way you know how it's symmetrical. It's symmetrical across that dotted line. And then our vertex is found by our x is the negative b over 2a. That's our x value of our vertex. The y value is found by plugging in the x value into the equation. So using function notation, I'm going to write it like this. F of negative b over 2a. That means I'm going to plug in whatever I get for that negative b over 2a and find out what comes out. It's kind of like f of x. The x is the negative b over 2a. So if I were to rewrite this standard form, I could write it as f of x equals ax squared plus bx plus c. Those mean the exact same thing. The only thing I swapped out was f of x and y. They're the same. It's just two different notations. Okay, so we're going to graph this by hand by doing the negative b over 2a, finding our vertex, drawing our axis of symmetry. So here are the steps. It says graph the vertex. And the y-intercept. The y-intercept is whenever you have a 0 for the x value and c. So in our equation, c is our y-intercept in standard form. Makes it easy. And then we'll draw our axis of symmetry. That's our AOS as a dotted line. And then once you have your y-intercept, you can reflect it over the axis of symmetry. So you count how far away it is from the axis of symmetry and then go to the other side. So that's called reflecting it. So reflect the axis of symmetry, or the y-intercept over the axis of symmetry. And connect to make your parabola. If the y-intercept and the vertex are the same, pick an on the left or right of the vertex and plug it into the equation. why it says in. Pick a x value on the left or right of the vertex and plug it into the equation to get another point. All right, we have 2 examples to do. All right, so here is our first thing. So let's look at it. Y equals 2x squared plus 4x minus 1. So let's look at the A. Let's label them. A is 2. B is positive 4. C is negative 1. So to open either upward or downward, you look at the A value. A is positive. So it's going to open up. Okay, the vertex is found by doing that negative b over 2a. So I'm going to use this little space here. X equals negative b over 2a to do the work. We're going to plug it into that formula. So x equals negative is part of the formula, so negative, and then b is 4, positive 4. So negative 4 over 2 times a. 2 times 2. So we'll plug that into the calculator. Negative 4 over 2 times 2. Go ahead and do that. I need your AirPod. So it's at negative 1. Were y'all able to get that? So let's fill in x equals negative 1. So let's go to the x-axis, go to where negative 1 is, and draw the axis of symmetry, the dotted line. So that gives us an idea of where the vertex is going to be. Okay, now we need to find the y value to the vertex, because I don't know if it's up here, or if it's down there, or if it's in the middle. We've got to find it. So we are going to plug in the negative 1 into the equation. So we're going to do f of negative 1. That means everywhere I see an x, I'm going to substitute in negative 1. So this will be, put it in parentheses when you plug it in. So negative 1 in parentheses. Oh no, I forgot the 2. Back it up. 2 parentheses negative 1 squared plus 4 times negative 1 minus 1. So put that in your calculator. Exactly like it appears. Negative 3? Is that what y'all got? Okay, good. So that's the y value of my vertex. The x value is the negative 1. The y value is negative 3. So I can write it as the coordinate negative 1 comma negative 3. So we'll plot that on the axis of symmetry. I think I'm going to do it in orange too. See that a little better. So -1, -3. Okay. What is the y-intercept? It is, let's look back up here, 0, c. So what's the c value? -1. So the y-intercept is 0, -1. So we'll plot that. 0, -1. The instructions say, reflect the y-intercept over the axis of symmetry. So here's our axis of symmetry. So to reflect, I would see how far away is it from our AOS. It's 1. So I go 1 to the other side. So I'm going to put that point right here. That's how you reflect it. And it has kind of like a slope of 2 for the first point only. We can't go up 2 over 1 each time because quadratics do a U shape, not a V. So I would go up 2 over 1, up 2 over 1 to get to just the second point. That's all I can get doing that. So we want to make this look like a U. So don't make it look like a V. We're going to do like this. And kind of extend it out. Make sure it looks like a U, not a V. All right, domain of a quadratic. It goes left and right to infinity. So what is that? All real numbers. And then the range is bottom to top. What's the bottom? -3 to infinity. And then do we have a maximum or a minimum value? Minimum, because we have a low value. The high value is infinity, so we can't say that. So it's a minimum. Okay, so it has a lot of steps, but as long as you follow the steps, you can do it. All right, let's go to the second one. Y equals -x squared minus 6x minus 2. So the first thing we want to do is label A, B, and C. What is A? But what is the value? -1, yeah. So I am going to go ahead and put that -1 there. And then B, -6. C is -2. Okay, is it going to open up or down? Down, because it's a negative in front of the x squared. The A is -1, so it's going to open down. Okay, the vertex is found by doing -b over 2a. So it's x equals -b over 2 times a. If it's already negative, then we change it to positive. Negative just means the opposite sign of what it is. So -b over 2a. So it'd be like -6, which is just +6. Over 2 times -1. Use your calculator to find out what that is. Don't say it out loud. Just write it down. Do alpha y equals to get that fraction. Okay, what'd y'all get? -3, okay. So then that means my axis of symmetry is at -3. X equals -3. Draw your dotted line down -3 on the x-axis. Then our vertex is found by doing f of negative 3. Plug it in. So it would be negative parentheses negative 3 squared. So make sure you put it in the right notation. Minus 6 times negative 3 minus 2. Lots of negatives going on there, so be careful with it. Make sure you put it in correctly. Mm-hmm. Yes. What'd you get for that one? So remember with the TI calculator, whenever you plug in negative 3, use the negative button. Whenever you do minus, use the minus button. But that out in front of the negative 3 is a negative. 7? Did y'all get 7? Yes. Okay, good. So equals 7. So this is our x, and this is our y of our vertex. So negative 3 comma 7. So let's do that. All the way at the top. Perfect. Okay, what is the y-intercept? 0, C. Nope, C. Negative 2. Yep. So 0, negative 2. It's way down here. And then it's 3 away, so you go 3 to the other side. Did y'all see how I got the y-intercept? Then you count how far away it is from the axis of symmetry. Then you go the opposite way to get to the other side to reflect it. Okay, if I wanted 2 more points, then I could do the first point from our vertex. So see how it's negative 1 is our A value? So I'd go down 1, right 1, down 1, left 1. And that would get our first 2 points closest to the vertex. So that gives me a better idea of what it looks like. So now make your U shape. Make sure it's not straight. It should look like a U. There we go. Okay, questions on how I got any of those? All right, domain. It's quadratic, so what's it going to be? All real numbers every time, unless you have some endpoints, but we don't. It keeps on going on and on. And then our range. You always want to go least to greatest, so look at the bottom. What is the bottom going to be? Negative infinity, because it goes on and on with arrows. Negative infinity up to what? 7. Then do we have a maximum or a minimum? Maximum. Good.